Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Jest, Tifr, IIT-Jam and other exams related to physical science. Okay, so this is the fifth part of this CSIR NET Physics PYQs of December 2019. Okay, so I'm going to start. Before starting the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes which are going to help you to crack the examinations related to physical science. Okay, so this is the fifth series of the CSIR NET Physics PYQ of December 2019. Okay, so I'm going to start with the question. So, question number first. Question number first is very good question. If rank of n cross n matrix, if rank of an n cross n matrix, A is M, where M and M are where M and N are positive integers with M is between 1 and n, then the rank of matrix A square is, then the rank of the matrix A square is, okay, options are M, option B is M minus 1, option C is 2M, 2M, and option D is M minus 2. Okay, so I'll solve it. Before that, let me just check the sound. Am I audible or not? Then yes, I'm audible. Okay, so I'll start now. I'll solve the question. So I will solve this question by example. Okay, so what we have been given is rank of rank of an n cross n matrix is M. Okay, rank of matrix is given, which is n cross n matrix, square matrix. Okay, and M and N are positive integers with the condition is given, guys. M is between n 1 and n. Okay, then the rank of the matrix A square you need to find out. Okay, so let we can take the sigma 1, that is polymatrix matrix. Okay, that is sigma x. Okay, polymatrix. We can take it 0 1 and 1 0. Okay, we have taken this matrix. This is the polymatrix. Okay, so from for this matrix, this is the matrix A. Okay, let's suppose the sigma 1 is matrix A. Okay, so for that we'll find the determinant, and the determinant is 0 minus 1, that is not equal, the 0 minus 1, that is equal to minus 1, right? That is equal to minus 1, that implies not equal to 0. minus 1 is not equal to 0, it means rank of matrix, rank of matrix is rank of sigma is 2, right? Because it's a 2 cross 2 matrix and its determinant is not equal to 0. It means the rank of this matrix is 2. Okay. Now there is a condition which is given, that is that clearly 2 is between 1 and 2, right? So 2 is greater equal to, satisfied this condition, which is because as per the question, the condition is given, m is between m is greater equal to 1 and less equal to n. Okay, so this is given. Okay, so uh, so this is the rank. Okay, the rank of A is 2, right? And so we have supposed that sigma 1 equal to the rank, so it means rank of matrix is 2. Okay, now we'll find A square. A square means A square, because we have supposed sigma 1 equal to A, right? A square is going to be 0 1 1 0 into A into A, right? 0 1 1 0, right? So we'll multiply it. So this is going to be 0 plus 1 and then 0 plus 0. Okay, so this is going to be 0 plus 0 and 1 plus 0. Okay, so this value is going to be 1001. Okay, this is the value, that is A square. Okay, and now for A square we can see, for A square we'll find determinant of A, that is we can see 1 minus 0, that is 1, not equal to 0. It means rank of A square is 2, right? So we so rank of A and rank of A square is both are 2. Okay, now from, so now we can see B, option B, C, B, C and D. Option B, C and D can't be correct option. Okay, can't be correct option because yeah, you can see this because of this condition. Okay, m is between 1 and m is between 1 and n, right? From this the rank of matrix cannot be m minus 1, right? This one, and even can and 2m can't be possible, right? And m minus 2 also can't be possible, because m is greater equal to 1, right? So so B and C, B, C and D can't be the correct options. That implies option A is correct. Option A is correct. Okay, so which is the correct? So here you can see option A is M. So the rank of A square is 1, right? Because these options are not possible, right? Very good question. These options are not possible. That is, and we have supposed sigma 1 equal to A, then we have found A square, and we've got rank 2 for the both A and A square, right? So option A is the correct one for this. Very good question. Okay, logical question. Next question, guys. Next question. Next question is, that is question number 2. It's also very good question. A particle of mass m a particle of mass m is confined particle of mass m is confined to a box of unit length in one dimension. Okay, length is the width or length is 1. Okay, unity 1. Okay, unit length in one dimension, in one dimension, it is described by it is described by the wave function. It is described by the wave function psi x equal to root 8 upon 5 sine pi x into 1 plus cos pi x. Okay, this is the wave function is given. For condition is given for x is between 0 to 1. X is between 0 to 1. Okay, x is between 0 to 1 and 0 outside. Okay, 0 outside and 0 outside. 0 outside this interval. Okay, this interval. So value of wave function is 0 if it is not, x is not between 0 and 1. Okay, 0 outside this interval. Okay, the expectation value of the expectation value of the energy. Well, expectation value of the energy in this state is okay. So options are, so we have to find out expectation value of energy, okay, in this state. So options are 4 pi square upon 3m h cut square Option B is 4 pi square upon 5m h cut square. Option C is 2 pi square upon 5m h cut square, and option D is 8 pi square upon 5m h cut square. Okay, so this is the these are the options. Okay, well, so we'll solve it now. So what we have been given is a particle of mass m. Okay, so which is confined to a box of unit length. So length of box is 1. Okay, in one dimension. Okay, so it is described, so it is in one dimensional infinite potential box. Okay, so it is described by the wave function. This is wave function is given and the condition is given. This value is this if x is between 0 to 1, otherwise 0. Okay, the expectation value of energy in this state we need to find out. Okay, very good question, guys. I have solved this type of question in quantum mechanics class. Okay, you can check it. Okay, in Dirac delta potential chapter I solved that this type of question. Okay, well, I'm going to start now. So we have been given the wave function. Okay, so wave function is given, that is psi equal to root 8 upon 5 sine pi x into 1 plus cos pi x. Okay, we'll simplify it. So it is going to be root 8 upon 5. This is complete root, guys. Okay, this is going to be sine pi x, very important step, guys, understand this. Okay, into root 8 upon 5 sine pi x cos pi x. Okay, Now what we are going to do is we will multiply by 2 and divide by 2 this one. Okay, so this is going to be root 8 upon 5 sine pi x plus root 8 upon 5, and this is going to be, we have multiplied this 2 sine pi x cos pi x by 2, right? So 2 sine a sine b is sine 2a, right? So sine 2 pi x upon 2. Okay, this one. So this is this value of psi, right? And now what we are going to do is we will normalize it. Okay, so since this is the one dimensional infinite potential box, okay, infinite potential box, and this length is 1. Okay, this length is 1. So so we are going to uh, normalize it. So it is going to be 8 upon root 5 into root uh, root 2 upon L, right? L value is 1 into so we can write like this. This is 1 upon root 2 into root 2 upon 1. Okay, because 2 upon L value is 1, right? Unit length. And similarly, this is going to be root 8 upon 5. There is a reason for doing this. Okay, so and this is going to be root 1 upon 2 into root 2 upon 1 sine 2 pi x, 2 pi x. Okay, yes. Now let me just check. Okay, so sine 2 pi x and upon 2 is there. Okay, so this will simplify it. So if we simplify it, so this value is going to be root 4 upon 2 will 2 get cancelled, right? Root 4 upon 5, root 4 upon 5, this is root 2 upon 1 sine pi x plus, we will simplify this, so this is going to be root 8 upon 5, root 8 upon 5 into this is going to be 1 upon 2 into 1 upon root 2, 1 upon root 2 into sine 2 pi x, right? So this value is going to be this is root 2 upon 1. Root 2 upon 1. Okay, so we know for 1D potential box, so this value is phi 1, right? Phi 1 equal to that is root 2 upon L sine pi x, right? And this value is phi 2. For this is ground state wave function, this is first excited state wave function, right? 2 upon 1, L is 1 here, sine 2 pi x, and if we solve this one, so this is going to be root 1 upon 5. Okay, root 1 upon 5 is going to be, right? So this is going to be, now value of psi is going to be 4 by 5 root 4 by 5 phi 1 first ground state plus root 1 by 5 root 1 by 5 phi 2. Okay, phi 2, this is the one. Okay, because here this is root 2 is also here. Okay, root 2, this one root 2, this one root 2 and 2, root 2 8 get cancelled, 1 upon root 5. Okay, this one. So now we'll check whether it is normalized wave function or not. Okay, so here it's a normalized wave function. How we are going to check? This is c1 c2, c1 square plus c2 square should be 1. Okay, So this is 4 upon 5, root 4 upon 5 means square means root 4 upon 5 plus 1 upon 5. So 5 upon 5 equal to 1. So this is normalized wave function. Okay. So now we have got the function that is normalized, that is psi equal to root 4 upon 5. If it is not normalized function, we will normalize it. Okay. And then this normalized wave equation is going to be 1 upon root 5 phi 2. Very simple, right? Now we can easily find out ground state energy. Okay. So this is yeah, so expectation value of the energy in this state. Okay. So expectation value of energy, this one, expectation value of energy in this state, this is going to be, we know expectation value is sigma pi ei, right? So that is sigma, that is going to be P1 E1 plus P2 E2, right? P1 means mod C square, this is C, right? So this is going to be 4 by 5, and ground state energy of ground state energy of one dimensional infinite potential values, we know that is pi square h cut square upon 2 m square, right? 2 m a square, right? So m a square, a is 1, 1 square is 1, 1 square is 1, 1 square is 1. Okay. So and then this is going to be 1 upon 5, 1 upon 5. Okay. 1 upon 5 and this is going to be E2, ground the first excited state of 1D, first excited state of potential box, infinite potential box is, we know, right? That is 4 pi square h cut square upon 2 ma square, right? A square is 1, so 2m. Okay. So energy is going to be, we'll solve this. So this is going to be this is going to be so he is going to be this one. Here we will take pi square h cut square upon 2m common. Okay. Pi square h cut square upon 2m we have taken common. So this is going to be 4 by 5, 4 by 5 plus here. So this common, so 4 by 5, right? 4 by 5. So this is going to be 4, 8 upon 5, right? So 8, 8, right? 8, and then if we cancel it, 8 and 8 will get cancelled by 2, right? It is going to be 4 pi square h cut square upon 2m. Okay, this is 5. This is 5m, 5m, yes, 5m, 5m, because 5 is there, right? 5m. This is the one. Okay. Well, so this is the one, guys. Okay. Have you made any mistake or everything fine? Just let me check. Okay. 1.54. Right. We solve it, and this is going to be this one. This is the answer, guys. Okay. This is the answer. And which option is matching? Let me just check. Option is matching. Option B is matching. 4 pi square h cut square upon 5m. Okay. 4 pi square h cut square upon 5m. 4 pi square h cut square upon 5m. Okay, so this is the answer. Next question, guys. Next question is, yes, this is 2m, right? Right. Next question is question number 3rd. Question number 3rd is, it is from electronics. In the circuit below, in the circuit below, very good question. D is an ideal diode. D is an ideal diode. D is an ideal diode. The source voltage, Vs equal to V naught sin omega t is a unit amplitude sine wave, and Rs equal to RL. Okay, so figure is given. This is the figure. Okay, this is fine. I'll make it in next page. Okay, so what you need to find out, the average output voltage, the average output voltage PL across the load resistor, across the load resistor RL is okay. Options are number A 1 upon 2 pi V naught. Okay. Option B is 3 upon 2 pi V naught. Option C is 3 V naught, and option D is V naught. Okay, I'll make a figure, then it will clear your doubt. So figure is the figure VL, and this is RS. This is RS. Okay, This is RS, this is VL, and this is RL, and this is PS. RS. Okay, so this is the question. Okay, so it is in the circuit below. D is an ideal diode source, and the source voltage Vs equal to V naught sine omega t is a unit amplitude sine wave, and Rs equal to RL, right? So this is the figure. This is Rs, this is RL. These are equal. This is ideal diode D. Okay, ideal diode D. And so what you need to find out, very good question, the average output voltage VL across the load register. Okay, across the load register, uh, you need to find out average output voltage VL. Okay, okay, so I'm going to solve it. So how to solve this? Okay, it's simple question. Okay, options are given. Okay, so first this is positive part of the diode and this is negative part of the diode. Okay, so for first positive half cycle, so because you can see we have been given voltage Vs, source voltage is V naught sine omega t, right? So this is sinusoidal input, right? The voltage is like this. So for first half cycle, for positive half cycle, okay, for positive half cycle, VL is going to be uh, okay. So for positive half cycles, so for positive half cycle, this diode is going to be forward bias, right? This is plus, right? So this is plus, right? So this is forward bias. Forward bias means the diode will act as a wire, okay, conducting wire. So in that case, the current is going to flow from here, and current will not flow from this resistance, okay, according to current rule, right? So there's a rule that current always flows from where there is no resistance, okay. So this is just a conducting wire, so current will flow from here. Always chooses the path where there is no resistance, okay. So for positive half cycle, we can see, so Vs voltage will pass through this, right? So you can see, so this is just agar if we make a figure here for positive half cycle, so this is going to be like this one just this, and this, okay. So this will just work as a uh, it will just going to work as a wire, and then this means the voltage across RL, that VL is going to be equal to, these are parallel, right? Voltage across VS, right? So whatever, so voltage across RL, that VL is going to be equal to VS, whatever voltage is in input, right? This we know. So from here, uh, VL is going to be V naught sine omega t, right? This is given V naught sine omega t. That is VL equal to VS, VL equal to VS equal to V naught sine omega t, okay, because this diode is working as a conducting wire for forward biasing. It's a case of forward biasing, okay. Next is for negative half cycle, for positive half cycle, and for negative half cycle. For negative half cycle, VL is going to be, for negative half cycle, understand here, okay. So this is negative and this is positive, right? So it means they are reversed bias. Reverse bias means diode will work as a broken wire. So this is broken just, okay. So current is going to flow from here, and these are the resistances, and these resistances are in series, and if we and also given, we have been given Rs equal to RL, we have been given, right? So in that case, for negative half cycle, the value of VL is going to be VL is going to be, that is Vs by 2, okay, or we can write V naught sine omega t by 2. How? Because we will take in this loop, right? In this loop, if we take it, I'll just explain it as well. So if we use VCL, uh, this is going to be Vs minus IRS minus IRL is going to be 0. So this is going to be Vs equal to 2IRL, Rs equal to RL, right? So IRL is going to be Vs by 2, right? And IRL means from in this figure, this is the resistance, right? IRL means that is Vs, that is VL, right? So VL equal to Vs by 2. From by this we got this value, okay, by voltage law we have used, okay, by KVL, okay. Okay, so these are the value of VL for negative half cycle and positive half cycle, and what we have to find, we have to find the average output voltage, okay. So average output voltage, how to find it? This is going to be V average is going to be 1 upon 2 pi integration pi to 2 pi V naught by 2 sin theta d theta, okay. This is the one. So this is going to be, we'll solve it, simple integration 1 upon 2 pi average V average, okay, V average 1 upon 2 pi, and this is going to be cos sin pi, the V naught will take common, okay. I'll solve it. So this is going to be V naught upon 2 pi, and will take common, that is cos theta, integration cos theta is minus sin theta is minus cos theta 0 to pi plus this is going to be V naught we have taken common, complete common, okay, this one, and this is going to be 1 by 2 minus cos pi to 2 pi, okay. Cos 2 pi value is 1 and cos pi value is minus 1. So if we solve it, so value is going to be 1 upon 2 pi V naught, okay. So this is the answer. So which option is my matching? 1 upon 2 pi V naught. So option A is matching, guys. 1 upon 2 pi V naught, okay. Very good question, guys. So you need to found first, you need to find for the first, you need to find for first positive half cycle, and then second for negative half cycle, okay. So this is the procedure. Very good question, okay, right. Next question, question number 4. Question number 4, okay. Question number 4 is, this is also a good question. The normalized wave function, the normalized wave function normalized wave function of a particle normalized wave function of a particle in 3 dimension in 3 dimensions is given by psi x y z, that is equal to nz e to the power, that is exponential, minus a x square plus y square plus z square. Okay, this is the wave function which is given, where a is a positive constant, where a is a positive constant, a is a positive constant, a is a positive constant, and n is a normalized constant, n is a normalization constant, normalization constant. If L is the angular momentum operator, if L is the angular momentum operator, the eigenvalues of L square and Lz respectively are: option A is 2 h cut square and h cut, option B is h cut square and 0, option C is 2 h cut square and 0, and option D is 3 by 4 h cut square and 1 by 2 h cut. Okay, so these are the options which are given. Okay, so the normalized wave function of particle in three dimensions in functions, the normalized wave function of particle in 3 dimensions is given by this. Okay, this is the normalized wave function is given, where a is a positive constant, n is a normalization constant, and L is a angular momentum. If L is a angular momentum of operator, so eigenvalues of L square and Lz respectively you need to find out. Okay, so it's easy question, I'm going to solve it. Okay, so psi is given, that is psi which is function of x, y and z, that is given nz e to the power, that is exponential, minus a x square plus y square plus z square. Okay, so this is the this is given. Okay, now we'll convert it into spherical coordinate system. Okay, this wave function we will convert it into spherical coordinate system, because as of now it is in Cartesian coordinate system. Okay, Cartesian coordinate system. So psi which is function of r, theta and phi. Okay, this is going to be n. Z value is in spherical coordinate system, value of z is r cos theta e to the power, that is exponential minus a, and this value is going to be r square, because x square plus y square plus z square equal to r square, right? In spherical coordinate system, x square plus y square plus z square equal to r square, and x equal to r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos theta, right? r cos phi, r cos theta, my apology, this is r cos theta. Okay, so we can write phi r theta and phi, this is going to be n r cos theta e to the power exponential minus a r square, right? Okay, so from here this implies the value of m equal to 0 and value of L equal to 1. Okay, so now we can easily find out the eigenvalue of L square is going to be, eigenvalue of L square psi is going to be, we know that is L square equal to this one, L into eigenvalues of L square. Okay, so that is going to be L into L plus 1 h cut square. Okay, eigenvalue of L square, and this is going to be L equal to 1, right? 1 plus 1 outside 1 into h cut square, that is going to be 2 h cut square. Similarly, Lz value is m, h cut value of m is 0 into h cut, right? That is 0. Okay, so value of L square and Lz, that eigenvalues of L square and Lz is, which option is matching? Option 2 h cut square upon 0. Option C is matching, guys. Option C. Option C. 2 h cut square and 0. Okay, 2 h cut square and 0. So these are the answer. Okay, very good question. Next question, question number 5. Question number 5 is, this is also good question. This is formula based question. Okay, from electromagnetic theory. Okay, so question number 5, this is the electric field of an electromagnetic wave. The electric field the electric field of electromagnetic wave, EM wave, is electric field vector is given. Okay, so this is E equal to iota cap root sine kz minus omega t, okay, volt meter inverse, the average flow of flow of energy per unit area per unit time, per unit area per unit area per unit time, per unit area per unit time due to this wave is, okay. Options are 27 into 10 to the power 4 watt per meter square. Option B is 27 into 10 to the power minus 4. Options are given wrong, guys. Okay, so I'm not going to write option, I'll directly solve it, because same options are given. No, this is not correct. Options are correct, guys. Let me write again. correct, 27 into 10 to the power 4 watt per meter square. Option B is 27 into 10 to the power minus 4 watt per meter square. Option C is 27 into 10 to the power minus 2 watt per meter square, and option D is 27 into 10 to the power 2 meter watt per meter square. Okay, so the electric field of electromagnetic wave is given, guys, and you need to find out average flow of energy per unit area per unit time. Okay, flow of energy per unit area per unit time is, that is S. Okay, pointing vector. This is because we know that S is, pointing vector is E upon T per age. Okay, so energy per unit area per unit time. Okay, this is energy per unit area per unit time is pointing vector, that is S, and that is equal to I. Okay, I. Okay, and the energy flow of energy per unit area per unit time is S, and that is I, and that is equal to, we know there is a formula based question it is, guys, you need to know. So 1/2 epsilon 0 E naught square C. Okay, very important. This, the energy per unit area per unit time I, that is average of S, that pointing vector, is 1 upon 2 epsilon 0 E naught square C, right? So here we can see we have been given the this one. We have been given the energy, right? We have been given the electric field of the electromagnetic wave, right? So here from here it is clearly seen √2 is the E naught, right? So this we can write E naught value is √2, right? Because E is in the form of like this. E is in the form of E naught I cap sine kz minus omega t, right? This one, kz minus omega t. Okay, so S is going to be, that is I is going to be a half epsilon 0. Okay, and then this one E naught square. E naught square means √2 square into C, 3 into 10 to the power 8, and 1 upon 2 into epsilon 0 values 8 into 8.5, 8 into 8.5 into 10 to the power minus 12 into 2 into 3 into 10 to the power 8, and this value is going to be equal to, almost equal to, that is I. Okay, this is going to be equal to energy per unit area per unit time, so that is going to be 27 into 10 to the power minus 4 watt per meter square, watt per meter square. 27 into 10 to the power minus 4 watt per meter square, this is the answer. Okay, 27 into 10 to the power minus 4. And which option is matching? Option B is matching, guys. Option B, this one. Okay, well, so this is the one. Next question. Next question is, this is also a good question, guys. Easy question as well. Question number 6. The values of A and B. The values of A and B, for which value of A and B, for which the force F equal to AXY plus Z cube, AXY plus Z cube I cap plus x square j cap plus bxz square k cap is conservative, okay. Options are a equal to 2, b equal to 3. Option B is a equal to 1, b equal to 3. Option C is a equal to 2, b equal to 6, and option D is a equal to 3, b equal to 2. Okay, so these are the options. Very simple question. So question is the value of A and B you need to find out, for which the force, this force is conservative. Okay, so for being forced to for being forced to be conservative, yeah, for a curl of the force should be equal to 0. Okay, so for conservative force, for conservative force del cross A, sorry, my apology, that is del cross F, that is F, right? Del cross F equal to 0. Okay, so this means curl of that is curl of F is 0, right? So this means x cap I j cap. Okay, so that means that is going to be equal to I cap j cap k cap, and the value is going to be del upon del x, del upon del y, del upon del z, and the values are axy, because F is this, right? Axy z cube plus z cube, x square plus bxz square, right? This is going to be equal to 0. So we'll find out. So this is going to be I cap 0 minus 0. This cancel, this cancel. This is 0, this is 0, because these are constant with respect to y and z. Okay, next, minus j cap bz square minus 3z square. Okay, this one, this right? This is x, right? B z square, right? And this is this one. This is for z 2z cube, right? 3z square. So it is going to be 0. Similarly, for k cap is going to be 2x minus ax equal to 0, because this one, right? 2x, and if you multiply, if you differentiate this with respect to y, so this is going to be ax, right? So this implies curl of f is 0, right? So this value is 0, so this implies we'll put the we'll find the values. So values are going to be minus j cap here we can solve, right? So here you can see we can compare the coefficient of ijk on right hand side. Okay, so this is going to be 3bz square minus 3z equal to 0, right? So bz square minus 3z square is going to be 0. From here b is going to be 3. Okay, similarly 2x minus ax is going to be 0. 2x minus ax is going to be 0. This means value of a is going to be 2. So value of a and b are 2 and 3. Which option is matching? Let me check. Option A is matching, guys. Okay, option A. This is the correct answer. Well, guys, before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes, which are going to help you to crack the examinations related to physical science. Okay, guys. Remaining thing we'll do in next class. Thank you so much, guys. Bye now.